This week we're going to learn about Windrose plots, how to make them, how to make a grid of them, and even how to put them on a map. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week, I want to talk about the Windrose plot, which is a plot that we haven't really talked about on a MetPy Monday before, surprisingly, and is handled by the Windrose package. But to get some wind data to plot, we're going to use the IEM, or the Iowa State Archive, and get 4 stations from around Colorado: the Charlie 99 Dakota Hills Station, the Denver Centennial Station, Longmont Vance Brand Airport, and Denver International Airport. So this will give us a nice sampling of along the Rockies, right in front, and further off to the east. So I've selected those stations, wind speed and direction. I'm going to get 1 year's worth of data for 2024 in a comma delimited format, including latitude and longitude, and representing missing data with M. And I'm going to save those results to my computer. So thanks to all of the hard work of the folks at IEM, we have a file that contains all of this data now. And it looks something like this. So we've got a column for station, a column for the valid time, the lon and lat, the wind direction, and the wind speed in knots. Okay, so let's hop over to a fresh notebook and get started. I'm going to import pandas as PD so we can read in the data. And from Windrose, I'm going to import the Windrose axis. Now, how do I know to do this? Well, I went and looked at the examples for the Windrose package. That's a great way to learn when you're working with a new package, is look at the examples, see how they show you to do things, and then adapt from there. It may not be exactly what you want, but it gives you a good starting point. All right, so the first thing is getting our data. So I'm going to read CSV. ASOS.CSV, our missing values, in this case, capital M represents a missing value. If we wanted to put more missing value markers in there, we could, but so far that's the only one we need for this file. And then I'm going to drop any rows that have missing values, because if it's got a missing wind direction, the wind speed's useless to us. If it's got a missing wind speed, the direction's useless to us for this plot. Okay, so if I look at my data frame, there we see it looks like it read in correctly. So next, let's make a basic plot. So I'm going to get some station data. I'm just going to plot a single station. So where my data frame station column is equal to den, we're going to keep that data. I am going to create an axis using Windrose axis dot from ax. And I'm going to create a bar chart on that axis with our station data. And that's going to be our direction. And I'm going to go ahead and call that values just so we get a NumPy array back. Speed in knots dot values. Normed equal to true, which means that we're going to show as a percentage of all the data instead of the absolute number of observations. And I want the bars to be tab red. So here you can see that we're going out to almost 12% on this outer ring. If I set norm to be false, then this is going to show the number of observations falling in each of these directional bins. But I think true is a more useful plot here for us. So what we're looking at is we see a lot of southwesterly flow as well as north-south flow, a decent amount in the west quadrant, but we don't really have a lot of wind out of the east. So that's great for one station, but I have 4 stations worth of data. And I want to plot all 4 of those as a multi-panel plot, a single figure, so we can compare and see what the different stations look like. So first we need to get the unique stations. So stations are going to be the station column of our data frame. or data series. And we want the unique values. And there they are, the 4 unique stations that we have. So now we're going to create our plot. We're going to import matplotlib.pyplot as PLT. I'm going to create a figure and an axis simultaneously using subplots with 2 rows and 2 columns. I'm going to go ahead and specify a square figure with fig size of 1212. And then I'm going to specify the subplot keyword of projection is going to be Windrose. And this is just an easy way to make all of those subplots have the Windrose projection. Now, axes is going to be a 2D array, and I want it to be 1 so I can iterate over it easily. So I'm going to flatten it. And then we're going to iterate, or write a loop, over the different axes and the different stations. Now, you could do this in a couple ways. You could zip, you could enumerate. I'm going to use enumeration in this case. So for I, my counter, comma, station in enumerate stations, I'm going to go ahead and get a handle on the axis by indexing into axes and assigning that to ax. And then we're just going to copy what's already worked in our plot up here, paste it down here, and we're going to change from din to use the variable station. Okay, so we're already pretty close to what we want. I'm going to set a title so that we know which station is which. Specify a font size, and let's see what we get. Okay, so we didn't get quite the result we expected. We got 4 individual plots and then blank grid. Well, it's because when we copy and pasted, we left this in, which was creating new instances of axis. So we get rid of that, and now we have our 4-panel plot, so we can see a very different wind pattern at some of these stations. In fact, at Longmont, almost exclusively north winds, 42% of the data being out of the north, whereas here at Charlie 99, we have northwesterly or west-northwesterly winds. Okay, so that's great, but I still don't know where these are on the map. I may be able to get an idea by looking at the wind directions, but it'd be nice if I could see them on a map. And that's what we'll be doing next week, learning how to put these on a Cartopy map and work with tools like OpenStreetMap. I hope that you found this useful, and I'll see you on next week's MetPy Monday.